Okay, we're going to look at this example. Solve the equation z squared take 2z plus 4 is equal to 0. And I could have solved this equation by completing the square method, as I did in the previous example, and then just solving for 0 by using the null factor law, or I could use the quadratic formula. Okay, so with the quadratic formula, we would have z is equal to negative b plus minus square root of b squared take 4ac divided by 2a. Okay, so we know that in this situation that b is going to be equal to the coefficient of just z. So that's negative 2. So negative 2 gives us positive 2 plus or minus square root of negative 2 squared, which is 4. Take away 4 times by a, which is the coefficient of z squared, so 1, multiplied by c, which is 4, all divided by 2 times a, or 2 times 1. Okay, so 2. Now let's just simplify what's occurring in this surd, and we'll have 2 plus or minus the square root of, and I've got 4 take away 4 times 4, which is 16. So 4 take away 16 gives me negative 12. 1, 2. Okay, we can continue to solve this. Now, if we're just looking at real numbers, we know that this is not possible. But we're using complex numbers, so we know that we can work out the solution as far as the complex set of numbers goes. And we're going to change that to 2 plus or minus the square root of 12 times by I. Okay, because I is the same as negative 1, square root of negative 1. Okay, divided by 2. Further simplify this, I'll have 2 plus or minus, and I can write square root of 12 as 2 root 3 divided by 2. Now, once I'm at the end, I can have z is equal to, and I divide both these two terms by 2, because the denominator is 2, and I'll end up with 1 plus or minus square root of 3i. And that's my final solution. And like I said before, we could have used the idea of completing the square in this situation and solving instead. Both methods will give you the exact same roots for that situation. All right, thanks guys. I hope that helps.